Hey, what's up, players? We're going to do another video in the series Bounty Hunter Training, and today's is going to be the cross-site request forgery. Now, this is an older vulnerability. It's not actually in the OWASP Top 10 2017 because it was assumed, or it is assumed, that a majority of different companies out there are doing proper mitigation against this particular attack. So it's not as prevalent, but it is still active, and I can attest to that because I was a senior AppSec engineer at a variety of different companies, and they both had this issue with the cross-site request forgery. They weren't actually doing it, mitigating it properly. So I figured it would be a good time to go ahead and discuss this. Now, this video series, Bounty Hunter Training, is specifically designed to teach you some web application security concepts so that you can use these to further your bug bounty programs that you do and bring home that sweet cheddar, you know what I'm saying? So the better you are at understanding the different web technologies and web application security technologies and attacks, the better you're going to be at your bug bounties. So that's pretty much the idea behind this series. So let's talk today about cross-site request forgery, and I'm using two different things. I'm using Portswigger Web Academy, Web Security Academy, and you can get to this for free. You don't have to have Burp Suite, which is what these guys create, Burp Suite. But you have to create an account at the page, and then you can go ahead and join their Web Security Academy. And then you'll see here that there's a variety of different topics that they go over here. And they also have labs that come on this page as well. It's just run within here. And we're going to use a couple of those today. I also go ahead and use Matilda, which is an older war game simulator. And I wanted to demonstrate a blog portion of how to do the same attack using that. So I trying to use a variety of different sources to be able to explain this. All right, so let's get into cross-site request forgery. So there are a few things that need to be in place for this attack to even work. This is not a direct attack where I'm directly manipulating you or I'm attacking you directly, you know, stealing session cookies and things like that. It's not a in-time attack in this case here. What I'm trying to do is this. If the victim we're trying to perform this attack on has admin privileges at a company, let's say that I'm the admin and I log in and I'm given a session cookie. And that session cookie allows me to do a variety of things, one of them being create a user. Now, as the attacker, I would like to manipulate you into creating my user account at your company. Now you're probably thinking, well, that's stupid, Ray. You know, ain't no self-respected admin's going to go ahead and just, at the whim of the attacker, just make an account for him. Well, that's the key thing. They're not going to know what's going on. It's going to happen behind the scenes, which is the beauty of this particular attack. Now, there's a variety of ways that the payload of this attack can get delivered, but a common one is by the attacker hosting their own web server and then having the actual form data there and have it auto-submit when the user gets tricked into clicking on the URL, maybe in a phished email or something like that, and they visit the page. It will auto-submit the form behind the scenes, and the idea is to have it sent to the web server as a post request. Let's say add user Leroy Jenkins, but it's going to be sent from the user that's the admin with the session token. Now, if the server doesn't have any other validations other than just the session cookie to validate whether this request, this post request can validly be made, then this attack will work. Now, if there's other extra measures in place to validate beyond just the session token, it gets a little bit more difficult and we have to figure out some bypasses. But that's kind of setting up the scene for what we want to do in this case, okay? So I'm the admin, I'm logged in, I have a session cookie, and I'm taking a break maybe from doing my normal work. I visit a page or I get an email that I think is a page that has to do with, you know, an update for the Windows computer we're doing at work or something stupid like that. I go to it, the form on that web page behind the scenes auto submits, and it looks to the server as if me, the admin, if I'm the one that's actually sending that post request, and I'm saying, please create this user, Leroy Jenkins, and it just does what it's told to do, and it creates a user because it knows this is a valid person that has valid privileges to do this. So, knowing that, let's go down to the first attack where there's no checks in place, there's no validation, it's just saying the user token. All right, so here we're saying that, let's go ahead and look at the lab. So I'm going to open this up, and I'm going to access the lab over here. Cool. So this one here says, and by the way, these are all solved by, I've done these already, but I can replay them. So it says here, the lab's email change functionality is vulnerable to CSRF. To solve the lab, craft some HTML that uses a CSRF attack to change the viewer's email address and upload it to your exploit server. And you can log into your own account using the following credentials: Wiener Peter. Anyways. So what the heck is this? Backstreet Boys or some garbage? Yep, that's what it is. All right, so I'm going to log in as Wiener Peter, and we'll see what happens from there. All right, so we'll say Wiener and Peter, log in. All right, so it says my username is Wiener, your email is wiener@normal-user.net. So it looks like what they want us to do is actually change the email address, and I can do that because it's my account and life is good. Now the attacker on the other end wants to have the email updated to their email. So therefore I get all the MFA, two-factor token requests for an email, that kind of stuff. I get all that sent to me. I'm going to open up our exploit server as well. So we'll open that up in a new tab over here. And this is where we'll host some business. But let's take a look and see what's going on. So first off, I'm going to do a video series really soon about Burp Suite to kind of give you a primer on it. But in this particular case, I'm just going to let you know that with Burp Suite, it's kind of like what they call an HTTP interceptor. Think of it like this. I have my browser set to send requests to a server, but I have it set in this case to go through this tool first, then this tool will send it to the server. The reason why I want to do that is so I can intercept requests and modify them and do things to them and all that kind of stuff. In this case, though, we're just going to use the HTTP history of things that I do. So I'm going to go ahead and highlight this to let it know this is the very last action I've done, so I can start from here, right? So I'm going to come over here and we're just going to come up with some email. I don't know. Let's say cnorris@chuck.com, because Chuck doesn't do push-ups. He pushes down the world. Little Texas joke there. All right, so update email. All right, so now it says your email is cnorris@chuck.com. Let's go take a look at, we'll see what that looks like. So first off, we see it's a post request. So in your normal everyday browsing, if you're not familiar with HTTP and requests and how they work, you basically have two different ones that you use the most: get and post. Get is exactly what it sounds like. It says, get me the web page contents and let me look at them. Post is saying, I want to submit something to the server. In this case being the form. And if you look at the source of this particular page here, whoops, wrong one. So if you look at the source of this page here, and right down here, you'll see there is a log. It says form right here. This is JavaScript here, or HTML, I'm sorry, for a form that's listed here. And it says the name is change email form. The action would be the email address that we're doing it to. The method we're using is a post. And the actual parameter name is called email. And then whatever the value is in this particular case. So knowing that information, if we come back here and look at Burp Suite, we can see here that the post request will always have some sort of body here down below. And we can see that the parameter is email. And the value is cnorris at chuck.com, and here's the URL, okay? So that's basically how that works. And here's my session token to say that I can do that because I'm Wiener Peter, and I can go ahead and do that. So what we're going to do in this particular case is I'm going to go over to my sweet old, get rid of this real quick here. I'm going to go to my, where is it at? Right here. My Dratus. You guys know about my Dratus that I use. And going to do a little cheat sheet here so I don't have to do all this typing. But I'll kind of explain what's going on here. So we're going to go to our exploit server, and we're going to go ahead in the body of the exploit server. I'm going to paste this. So it says here the form method equals post. So I'm making my own form. The idea is that I'm going to use the same parameters that the form on that page is using, but I'm going to have it submit a different email. My email, leroy@jenkins.com. Leroy Jenkins. And the idea is that I want it to go ahead and submit it when the victim visits my web page. Okay, we're not, obviously we don't have two people here to be able to do that, but on this lab, we can click view exploit and it will run the exploit as if the user visited the page. And you can see right here that it actually does the auto submit right there. It says take the very first form that's in the page, which would be this one, and submit it. So when the person visits the page, this will run, okay? All right, so what we need to do is first we need to get the URL of this request. So I'm gonna say copy URL, and we'll go back here and let's go ahead and put that in under the action portion. All right, and then we see input type, hidden email, name, email, and this is the one I'm putting in. This is the one that I'm saying is my email as the attacker, and then I wanted to submit. So I'm gonna go ahead and store that on my web page. Okay, and if you were doing this lab, it would show up here that you solved the lab, but to fully test it, let me do this real quick. I'm going to scroll down here so we can see, I'm going to highlight that right there. That's our last request that just happened, and we can see, obviously, that the email currently is this. We want it to be Leroy@LeroyJenkins, right? So I'm going to go ahead and click on View Exploit, which is essentially running the exploit, as if the victim visited the page and did it. You'll notice, look at that, LeroyJenkins.com. So without them knowing it, I actually had them submit and create an email or change their email on this account to my email. And they didn't even realize that actually happened. And let's go look at the request that went through once the person visited the page. So we can see here, there it is. There's the post request that's running behind the scenes, okay? And all they had to do was just visit my web page. That's it, okay? So this is where the crafty phishing tools and all that kind of good stuff come into play. All right, so that is basically, with no protection, what you would come across in a normal situation like that. So you can see that it can be pretty dangerous depending on what the victim actually has access to do. Because if they have access to create users, if they have access to, the direct deposit information or what have you, then I can try to manipulate that person into doing pretty much whatever dastardly deeds I want them to do. So a lot of times what they'll do to protect against this is they'll create something called a Csrf token. So the idea of this is, depending on if you're using, it's supposed to be server-side generating it, but depending on if you're using the client-side frameworks or what have you, one of the two here will generate a Csrf token. So just a random value, and you want high entropy on it, so you want to create the token as if it's a really solid cryptography, and you don't want it as a cookie. That's not preferred. And they'll generate this token, and then they'll send it to the user. Okay, and we're talking about the victim in this case, the user. Now here's the thing. Whenever the user now submits a post and wants to change an email address, it doesn't just want the cookie to see if they can actually do it. Now it's additionally asking that we send this token along as well, and the server, being the one that generated the token, will validate that token with the one they hold to verify if not only the session token allows them to do what they're doing, but also that it was intended. Okay, that's the key thing. Was the request intentional? And the key part of that is that if I sent the Csrf token as a user, that means I intend to go ahead and send this request. Therefore, the server will then process it. Now, Some companies implement it in the wrong way, but the proper way to do it is you'll see it in the actual post body itself. And I'll talk about something about Angular in a minute, which I've come across and still have not found an answer to in my workplace. But I'll talk about that in a minute. So when they get this token, let me just show you kind of what it looks like. So we're going to go down to this one here where it's dependent on the actual request method. I think that's the one. Yeah, let's do that. So request method, open token, and access lab. All right, so on this particular one, it's better to just kind of show you what the token would look like. So to solve this lab, use your exploit server to host an HTML page, just like we did just a minute ago. That uses a CSRF attack, and again, we have Wiener Peter as the main dude. All right, so I'm going to go ahead and do a regular submit of a change email so that you can see what has changed as far as what the request is expecting, because now you'll see it actually implement make sure my intercept's off. You'll see it actually implement a token itself, a CSRF token, to be able to do that. So I don't know why it's taking forever to do this. So let me pause real quick while I'm waiting on that. Oop, there it is. Okay, I was going to pause for a second, but I see it has popped up. All right, I'm going to go ahead and open this exploit server here. And let's go ahead and log in as our guy. I don't want to keep saying it because I just keep laughing at it. I'm so juvenile. What can I say? Anyways, so I'm going to change this again. We'll say cnorris at chuck.com. Okay. And let me go ahead and verify. Let me select down here. Bing. All right. So I'm going to go ahead and update my email. So it changed my email just like it's supposed to. And we can see here, account change email. There'll be something a little different this time. So let me scroll this up here. Now you'll see there's a new token here called CSRF, right? So in this case here, we now actually have the token and we have to submit that. If we don't submit it, then we run into problems, right? So for instance, if I send this to a tool called the repeater, it allows me to replay the same exact request over and over so I can try different things. So in this case here, if I did a send and follow the redirection, it should give me a 200 OK. Now if I go ahead and manipulate this last character and change it to an A, for instance. Oops, I'm sorry. That's the wrong one. Let me go back. There we go. So if I manipulate the actual CSRF token and say Q for the last one, and try to submit it, it'll say invalid CSRF token. So it is checking that we actually do have a CSRF token. It will not accept the submission if I don't send the proper token. Okay, so that's the idea behind that. So what are we going to do here? We're going to go over to our exploit server, because what sometimes happens is they use the wrong method. Now, in HTTP, if you're not familiar, there are what they call HTTP methods. And like I mentioned before, your two main ones are post and get. Whenever you're doing let me pop this over here. Whenever you're doing a validation, or let me rephrase that. Whenever you're doing a state change of any type, change an email address, add in a user, some sort of action where you're changing state, it should always be a post. And should always have the change or the whatever the values are in the body. Right, in the post request body. It should never be done as a get. Get should only be visit the page, give me the contents. That's it. What happens sometimes when you're doing the CSRF validation, you really only need this token when you do a post. Because if you're doing it proper at your company and you're saying every state change has to be a post, then every other thing like get, head, trace, those have no relevance for a CSRF token because there's no need for it and we can't put it in the body anyways. So if we don't actually whitelist it and be very explicit to say that it has to reject it if a post with a CSRF token is missing or malformed or whatever, then we run into the issue where I could send a get instead of a post, still keep it pretty much as what you're seeing here, and get by, because what will happen is, even though it's asking for a token, it's not actually doing a validation against GET requests, because you've already said to yourself in your company, we're only going to validate Csrf tokens on post, because that's the only place that Csrf tokens should be sent. But if you're not explicit about it and not actually stopping request based off of that concept, then you run a problem. So what I'm going to do is I'm going to actually change this post to a GET, and I'm going to verify and see, does this actually allow me to be able to go ahead and put in, submit this without a token? Because you got to remember, the attacker in this case does not know the value of the Csrf token, because that has only been given to the victim. And again, as I mentioned at the beginning, this is not a direct attack. This is not a man-in-the-middle attack. I do not have access to the victim's computer, nothing. I don't know anything that's going on that guy's computer. So I don't know what the Csrf token is. So when I do the step I did for the previous lab, where I have them visit my site and it auto-submits a form, I'm just auto-submitting the form, but I'm not sending the token because I don't know what it is. Now that's where you can get into what they call cross-site scripting, and you can do document.cookie type of attacks to try to see the cookie value, and then you now know it and you can insert it in your form. The issue with that may be that the Csrf token is a single use only, but that's not always the case. A lot of companies will do it for long periods of time with the same token, which is not recommended. So anyways, knowing this information, okay, we're going to go ahead and get the URL first for the request, because we want to do it based off of this one particular request right here. So we'll copy URL, and we'll put it right here. Okay, just like that. All right. So let's go ahead and store that and see what happens, because again, we don't know what the actual Csrf token is. So I'm going to store that. Sweet. And then we'll run our exploit, but first let's go ahead and verify. We'll select there. And again, I'm changing it to Leroy Jenkins, whatever, jenkins.com. So we'll go ahead and view the exploit. Bing, right there, check that out. So you remember when I had it in that repeater that if I changed or modified a value, it said invalid Csrf token. That's because it was checking that on a post. This time I did a GET and I got through. So if you look here, we'll see the account change right there, and you'll see it's a GET. Because it was a GET in this particular case, look at what it did here. It actually put it right there in the URL. And then from there, the response 302, and then we follow the redirection, and it actually goes ahead and gives us a 200 OK to be able to go ahead and get the result that we did right here. Okay? So that's where they're actually not being explicit to say we only accept posts for state change, everything else is discarded, and we only validate Csrf against post for state change, everything else is discarded, right? So more of a whitelist approach to it, if you will. So let's take off those. Now, there are other situations where, what if the token's not even there, right? Because, the server issued the token and the client's side framework or whatever is sending it and inserting it into the form and sending it to them. But what if it's not even there? What does it do? So in this case here, if they actually are not complete with their validation process and they say, well, we'll just skip the validation token if it's not there. We'll only validate if there is a present token. So let's go ahead and see what happens with that. So we'll open this one up here. Access the lab. And let's see, again, we're Wiener. So this one here, solve the lab, your exploit server. Use it to host an HTML page that uses a CSRF attack to change the viewer's email address, and you can log into your own account using the following credentials. So basically, it's going to be the same sort of attack in this particular case here, but we're going to go ahead and send it to the repeater and just kind of show you that way, because we already done the exploit server multiple times. All right, so let's go ahead and Wiener, Peter, and we'll log in. Okay, so again, Wiener at normaluser.net. Let's go back over here. And let's grab that particular one, which is post. Whoops, I'm sorry. I actually have to change the email address. C. Norris at chuck.com. Update email. And let's grab that and send it by right-clicking and go into Send to Repeater. That allows me to replay it multiple times. Now, I just want to see if the actual one will allow me to modify this here on the fly by removing the CSRF. First, let's manipulate the token to see if it actually sees that. So we'll just change that V to a U. We'll do send invalid CSRF token. Okay. So in this particular case here, what if we just go ahead and say no CSRF token whatsoever? And I will change this to CNORS2, let's just say. And then send and follow redirection. Bing! So then we go down here, right there, CNORS2 at chuck.com. So it changed it, and all I did was just remove the CSRF token completely out of the picture. So there's ways to do the mitigation of this. Like I said, the most prominent one is to do the token approach, where you submit the token. But again, you have to be very specific and explicit to say it's only on post. We only accept post for state change, and the token will have to be validated in there, and you have to have the token present. It has to be there on a state change. If it's not, we don't accept it. Discard it. So you have to be very, very specific about your defense. Now, before we move into the last thing that I want to show you here with the Matilde one, there is an issue I come across in my workplace. The workplace I work at, I'm the senior AppSec engineer, so I do all the DAST and IAST and all that kind of stuff. And our main language is Java for the back end, but for the front end, most of it is Angular. If you're not familiar with Angular, it's a JavaScript front end that it's a client-side scripting type of deal, where it actually has quite a few things built into it for protections like XSS protection and things like that. So a lot of developers like it because of all the built-in features of it, that it does pretty well for client-side stuff. Here's the issue. Whenever you submit a cookie, okay, so when I ask for a web server, I send a request to a web server, and in order to maintain state, because HTTP by itself does not have statefulness, meaning it doesn't remember me for multiple requests. Without cookies, I would have to visit a web page, click on it and see what's on that page, and then when I click on another link, I would have to log in again and get another acceptance to see the next link, and then I would have to click on another link and I would have to log in again. So essentially we don't really want to do that, so they made these things called cookies that allows us to store session information. And what they do is the server will create these and send it to us as a client, and whenever we send a request, our browser will include that particular cookie in the request, so the server knows who's asking for it and what permissions do they have, authorization-wise in some case, to do whatever they want to do. So in this particular case, with a cookie, you have a couple attributes that you can add to the actual cookie itself. One of them is called secure, and one is called HTTP only. There's another one called same site, which we'll talk about a little bit later. Now, with the secure cookie attribute, what you're saying is that whenever the request is sent to a server, if I have the secure attribute on that cookie, I'm saying do not send the cookie with the request unless it's over HTTPS. So yes, there are still some sites out there that don't do encryption and they use HTTP. And we're saying don't send that, because anybody with any type of packet sniffing can see that in clear text and view our cookie. And we already told about before where, the attacker in the CSRF deal doesn't know the cookie value. That would actually give them that value because it's sent in clear text and they can view it. So the other one is called HTTP only, which kind of confusing because some people think that's the one that I just mentioned. But HTTP only says no scripting is allowed to access cookie information. For example, in JavaScript, there's a function called document.cookie. And when I do an alert, document.cookie, I'm saying access the cookie information, the session cookies, and pop them on the screen so I can view them. So I'm accessing a cookie with JavaScript, reading it and displaying it to whoever asks for it. So when an attacker does a cross-site scripting attack that does that document.cookie and has it sent to them either through another server or some way, it's essentially saying read the information from the cookie and send it to them. That's how an attacker can find out the Csrf token value, is by doing that. So we put HTTP only on it to say no JavaScript, no scripting is allowed to look and view or manipulate or do anything with this cookie. Okay, so that will protect us from a lot of different XSS attacks. Here's the issue. Angular, in their infinite wisdom, which I still can't understand, they have a cross-site request forgery protection built into the platform. What it does is it says when the server generates the Csrf token, Angular will read that token, that cookie, whatever they sent it as, and they will then transform it into a header called X-CSRF-something. I can't remember the full name of it. Anyways, it makes it as a value for a header. And then from there, it will then validate that that was being sent. Now, here's the issue. In order for Angular to read that information, if you created that Csrf token in a cookie format, it can't read it if you have HTTP only on all your cookies. And they specifically say that on the Angular site, in order for this Csrf protection to work, you have to disable HTTP only on your cookies. Now, to me, that's not a good trade-off. I don't recommend that. So I had a little debate with the developers at my workplace, and we were trying to figure out. I went on a variety of Gartner calls. I went on some different community forums. I went on some different security events and talks and asked at least 15 people that were peers in the industry, how do we get around that? What's the issue with that? Not a single person has come up with an answer. Not one. If you can come up with an answer, put it in the chat for me in the YouTube video in the comment. Not one come up with it. So I came up with because whenever you're working with developers as an AppSec engineer, you can't just force your way on the developers and say you have to do this, because then you'll get no working relationship. There are some times where you'll have to compromise and have a different approach to try to fix the same problem. So what I had come up with in this case, and what we told them, is we're going to use the same site cookie attribute, which is created by Google, to combat Csrf. It was designed specifically for that. Now, I still recommend the token approach, right? I still recommend that more. However, if you run into a situation where you're running Angular and you do not, as I believe, and you do not want to remove HTTP only from your cookie attributes, you have to do that if you want the Angular Csrf protection. It has to happen, or you don't have it. So to get around that, I basically said, anytime that I do a Burp Suite scan of your application and it comes up with the flag saying you don't have an anti-Csrf token, I'm going to mark that as a false positive, because I see and I know that we have the same site attribute on the cookies. So that was my my compromise with that. And it seems to be working pretty good for that. Okay. So do keep that in mind when you're thinking about prevention. If you do use Angular, there is that issue. And if you have an answer for me, I would love to hear it in the comments on my YouTube video for that. All right. So let's talk about the last one here. So in this case here, we have the blog, and we have a add blog for anonymous. Now let's go ahead and view the source and see kind of what the code is here. I think it's all the way towards the bottom. So let me scroll down here. All right, so it looks like we have, where's that? Looking for a form. Okay, looks like, I think it is right up here. Is this it? Form, right there. Add to your blog. Da, da, da. Is that the same one? Yeah, add new blog entry. There it is. So in this case here, action is this web page. Method is this post. Looks like it's using some sort of application form or URL encoded. Name is Csrf Token. Values, all kinds of good stuff there. But I think there was some other values being used as well, if I'm not mistaken. Hidden values. But we'll check it out here in just a second. So let's go ahead and make sure our Burp Suite here is all the way to the bottom. And I'm going to go to my sweet little form over here. And what we're going to do is I'm just going to go ahead. Actually, you know what? Let's just first just enter something in here. And we'll see what it looks like in Burp Suite. I'll say Leroy Jenkins. Okay. Save blog entry. And I'm not logged in as anybody, so I'm anonymous. And if I go to view blogs and I choose all, there it is, right? So let's take a look at Burp Suite and see what that actually looks like. So here's the post. Let's look at the request. All right, so right there we have this parameter, Csrf Token. We have this parameter, blog underscore entry, which looks like whatever the blog wants to post is right there. And then we have this parameter, add to your blog, PHP submit button, blah, blah, blah. There we go. So we know we have that. We know it's the add to your blog PHP, and we know it's a post. So knowing that information, I've gone ahead and ahead of time, constructed this, and I'll explain it here as I pop it in. Over here, let's go back to blog. So basically what this one is doing, actually it's probably easier to see it through here, is it's doing the exact same form that this one is asking for. It's using the add to your blog for the action. The method we see is post. You remember seeing before the ENC type is there. Now you remember that in our burp intercept, we saw there were 3 parameters. These are the names of those parameters, right? And we can see right there is the value Leroy Jenkins. And then we have, what's up? Now this is what I actually want to be in the blog. This, it will be the name that you see on the actual page. And what I'm trying to do in this particular case here is I want to do what's called an on mouse over. And what that basically means is exactly what it sounds like. If I move my mouse over Chuck Norris rules, which is the value that you'll see on the blog page for whatever it is, if I move my mouse over that, what I want it to do is I want it to submit what's up as the actual blog entry. Now, obviously, I'm going to pretend that on my end, me, the victim, doing this mouse over movement, is that I'm not actually intentionally putting in a blog entry for what's up. Okay, that's not my intention. But it is happening nonetheless behind the scenes whenever I'll mouse over Chuck Norris rules in this case, okay? So let's go ahead and come over here, and we will save our blog entry. And then, yep, right down there. So if we go to View Blogs, watch this here. I'll go Show All. And right there where it says Chuck Norris rules, I'm going to move my mouse over it like that. And you saw, I didn't click anything. It just automatically changed. But look what it has right there. See that? What's up? So it submitted it on the behalf of the anonymous user. Again, if I highlight it, mouse over, again, I didn't click anything. We see another entry for what's up. Highlight it, bing. We see a third entry, so you get the point. This is where using things that aren't specifically XSS formatted like script or whatever, we're using an on mouse over event here to really fool make sure that the person doesn't know these things are going on. All they're having to do is just move their mouse across the page. Once they hit that one line of text that we have, it's actually going to submit something. Now, obviously, this is just putting a blog post. But what if the actual form that I was having to submit on MouseOver was to create myself as a user, right? Or to give me permissions as admin, and when I'm a standard user. So if I know that the person that is going to be viewing the page and mousing over is an admin at this company and has the privileges to do these things, I want them to do things that are admin-like commands on my behalf without them knowing it. That's the idea behind it. So pretty cool stuff. This is pretty crazy that this still happens these days. Not as prevalent. Like I said, it was in the OWASP 2013. They took it out of the 2017 one because, again, most people would implement the token approach that I mentioned, unless, of course, you use an Angular, because I don't know what's going on in their brain. I have no clue why they need to take our CSRF value, our token value, and convert it into a header. Why can't they just take the value we give them and validate it? I don't understand that. It doesn't make any sense to me. But I digress. That's a talk for another day. So if you do know the answer to my question about that, post it in the comments and let me know, because I would be glad to figure it out. Because 15 calls later and Gartner meetings, I've stumped all of them. Not one person, not one, has been able to give me an answer. They're all stumped. They don't know what the deal is. And to me, it boggles my brain, because that would tell me that the majority of these people are not setting HTTP only on their cookies, because I know they're using Angular, because they told me they are. So if they're, one of two things are happening, or maybe both. One, they're not setting HTTP only on the cookies, or two, they're not using the anti-CSRF built into Angular. That's my guess. But anyways, hopefully that helped you today with this sort of thing. If you do come across this in a bug bounty and you do want to attempt these sort of things, this is what they call cross-site request forgery. Still works in some cases. Like I said, not as prevalent, but it's good to put in your tool belt for your bounty hunter training. So until next time, hope you guys enjoy it. We're going to come up with another bounty hunter training here shortly with some documentation as well. Till then, peace out, players.